Right. Question number 35. So this is regarding isomerism. So when you have isomerism, okay. So isomerism, we go with constitutional isomerism. Or normally structural isomerism, and we go with stereoisomerism. So stereoisomerism, you have cis trans, which is called the geometric isomerism, and then you have chiral, the optical isomerism. So this is normally what we learn. And when you have optical also, then you can consider about enantiomers and diastereomers. So this question is mainly related to that part. Okay. So let's go with the question. A pair of stereoisomers which are mirror images of each other are known as enantiomers. So when you have a chiral center like this, okay, with 4 different groups, so we get the mirror image. Okay, so we get the mirror image. So mirror image is very similar to its original structure, but the only difference is this mirror image cannot be superimposed. This term is very important. Remember this term. Superimposed, cannot be superimposed. Okay, so a pair of stereomers where mirror images of each other are known as enantiomers. Since it is stereoisomers, so it becomes to this one, and it becomes to optical because they are considered about enantiomers. Okay, but but don't forget to become enantiomers. That is very important. Don't forget to become enantiomers. This should not be superimposed. Okay, for an example, see the screen, right? So let's say this is your one enantiomer and this is your another enantiomer, okay, which is your mirror image. Okay, so this is my enantiomer, this is my mirror image. Okay, so can I superimpose these two? You will automatically say yes, I can superimpose like this. So I have superimposed. So these cannot be optically active, and these are not enantiomers, real enantiomers. Okay, but superimposition means not like that. Okay, it is either like this, or you rotate this in a certain way and you overlap like this. Okay, and when you overlap like this, you think this is superimposed. This was like this. I converted this to 180 degrees and I can overlap like this. So you think this is overlap. So these are not optically active. No, this is optically active. Why? See, when you take this, do you see the same thing? No, this is my palm. This is inside and here you see the outside. So these are not still overlapped. Okay. So this is my mirror image. So we think that when I do like this, it is overlap. No, you can still need to understand this is not still overlap. Okay, because the same structure, this is the inside and this is the outside. These are not overlap. Okay, so this is very common with the molecules, because when you have a mirror image like this, you try to rotate. You can rotate up to 180 to 360. So not 360, which means the same molecule. You try as much as possible to rotate this and see whether this can be overlapped to this one. Okay, so when it is cannot be overlapped, or we say superimposed, not overlap, superimposed, it becomes enantiomers and they have optical activity. Okay, a pair of stereoisomers which are mirror images of each other are known as diastereomers. No, this is not correct. This is wrong because they are enantiomers. A pair of stereoisomers which are not mirror images of each other. So which are not mirror images of each other are known as enantiomers. So automatically this is wrong because they are the mirror images. A pair of stereoisomers which are not mirror images of each other are known as diastereomers. So this can be correct. AD can be correct. So your answer is 4. But I would like to elaborate something regarding these enantiomers and diastereomers. Okay. So I will quickly use the board. Time is also running out. Okay, so what shall we do? Like, so let's say there is a carbon like this, chiral center. And there is OH group, there is a CH3 group, and there is a H group. And what I'm going to put here, I will put another carbon like this. Okay. And I'll put like Br here, hydrogen here, and chlorine here. Okay. So in this compound, we have 2 chiral centers. This is one, this is one. Okay. So let's say this Br is on top of the plane, for an example, and this hydrogen is like in the bottom of the page. Not bottom, inside this plane. Okay. When you want to consider this as an enantiomer, this is what your enantiomer look like. So I will, this part is BrClH. Okay, so this carbon and hydrogen, chlorine and bromine. So when you have this one, it will be like this: hydrogen and chlorine, and Br will be like this, and there will be hydrogen, oxygen, CH3 and hydrogen. Okay, right? You understand? Mirror image of this is this. So this is enantiomers. Okay, but now check what I'm going to do here. I will draw another compound based on this: CH3, OH, hydrogen, and here Br is inside the plane, hydrogen is outside, and chlorine is same. Okay. So here still you can see this is a chiral center, this is a chiral center, this is a chiral center. But these two are not enantiomers. Why? This, with respect to this, is enantiomer, but these two are typically called diastereomers because these two are not mirror images, because here Br is outside, here Br is inside. Can you understand the difference between enantiomer and diastereomer? Because enantiomers are these two, where even in the mirror image, the Br is outside the plane. But when you consider about diastereomers, the mirror images are not each other because one Br is out, one Br is inside, but still they are chiral. Okay. Can you understand the difference between enantiomers and diastereomers? This is the easiest possible way to explain the difference between enantiomers and diastereomers. Okay, because normally we don't talk much in your syllabus, these enantiomers and diastereomers, but you need to understand what is actually happening. Right? So enantiomers, mirror images with chiral centers. Diastereomers, still they have the same chiral center, but you can imagine the position of Br is different. At one position Br was outside, the other position Br is inside. So that is why these two become diastereomers, because all other properties are same. Two chiral centers. Only the position of Br change and they become diastereomer. And when the position change, it does not become mirror images. That's the idea. So did you get this point? You don't need to get much things here, but just you need to understand what is the concept behind. Okay. It is always easy to consider with a chiral center because it will give more idea to take, more ideas to think, more time to think, and more things will come into your mind. Okay, why this is a mirror image, why this became a chiral center, and why this is diastereomers when you still have a chiral center. Think about those factors. Okay, so what about others? So I have some answers here. Yes, what about others? Try to go through it and see. Okay, so this is what we discussed right now. Pair of stereoisomers which are mirror images of each other known as enantiomers, and pair of stereoisomers which are not mirror image of each other are called diastereomers. So they are still stereoisomers. They show this optical activity. You understand, right? They are stereomers. They show still this optical activity. These two and these two. But these two are called enantiomers because they are mirror images and they cannot be superimposed. But these two are not mirror images. They are diastereomers. That is why they are diastereomers. Okay.